Okay, I fixed the two-string problem with Enchantum. So now we can continue with the actual bug as described in the description. I really don't see a way that this can return the wrong value for, well, because of a 64 times 64 board. But it has to do with the fact that the board is so big. It's quite a big function as well. A bit too big to step through, I guess. Let's try to understand it. It should, I think, shouldn't it be like the exact same thing as 16 by 16 board? Except that one works. Maybe you can step through it side by side and see what the difference is. I think that's probably the easiest thing. Can't remember writing this anymore, and therefore also not what exactly it's doing. Okay, I'm gonna try anyway. Let's try to figure out what is it. Let's try to understand what this is doing. So the current board is that one position. Neighbors out is a vector, I think. Every time we add something to neighbors out, the neighbor should be incremented. Definitely happens here. And here, and here, and here. And there, and here, and everywhere. Okay. It does not get incremented anywhere else, I guess. Okay. So what happens below this line? These are all cons expressions. To success north means we can step one step to the north. Did not step next to the other king or put ourselves in check. Okay. Given the position, the king can only step east. So this should not happen. This should happen. This should happen. The rest should not happen. So you can figure out, I guess, which is the other one that happens and then go backwards. Need to set a breakpoint here. Let's just set a breakpoint here. 418. Nope. I have to remove black king. The black king is at 0, 0. That is correct. Print the white king. The white king is at 0, 2. And it is. Print the white rook. The white rook at 0, 1. And it is. So we have the coordinates of the 3 pieces. XY encoded delta. Comment says calculate the difference between the coordinates of the 2 kings as the other king minus the king that is to move. We encode these deltas as delta plus 2 stored in an unsigned int. Okay, that means, well, without a plus 2, delta x is 0 and then delta y equals the other king was 2 minus 0 is 2. So that would be plus 2. It's the other king minus the king that is to move, which is 0, 0. Yeah. And then minus 2, so we should get minus 2, 0 in this array. And to move is black. Therefore, Well, we do this, and now ridiculous. Oh, that's +2. It was 0, 2, +2, +2, +2. Yeah, of course, +2. Yeah, okay. So instead of 0, 2, we get 2, 4. So far, so good. At least that corresponds to the comment. All squares around L, where L is just that point here. I think this is where the king is. And you have no idea why we need this. Well, this is a cons expression. This cannot go wrong. Calculate the squares that are blocked by the enemy king. I guess we move this this square around L that we had to this point around C. And then these three are the squares that our black king cannot go to, because the white king is on C. This means that is blocking anything at all. Well, we had 2, 4, so yes, this is true. This means the enemy king is on A through P, and it is because it is on C. And then we shift blocked by L left with 8 times that value in X, and sorry, the value in X plus 8 times the value in Y. Well, this was 2, I think, yeah, and the other one is 4, so it is 2 plus 8 times 4. This is 32, so 34. So at this point, shifted 34 there. Well, this is 8. So 1, 2, 3, 4, and then 1, 2. Yep, it's shifted to the C. So this value now should be something with 8 bits set. One, 2, 3, 4, 5, 6, 7, 8. I'm gonna assume it's at the right position. You can also see it here, yeah, 2, 4. West of king. These masks are used to mark squares attacked by the white rook relative to the king that is moving. West of king. So that is 2 zeros here and 2 zeros here, and then we have the 1, and then we can go down 3. So that is B, and then 2 down. D3. No, we should have D3, because the king is here. Hmm. This is wrong. Or not. Is it doing the same thing here? So you have 2 zeros. And then 1, 1, 1. So it thinks the king is here. 3 down. Maybe I just don't do the top zeros. Those are the most significant bits anyway. Need to see the bottom. So let's look at the bottom. So there is 2 zeros from the bottom. And then we get the 3 ones. Yeah, so 2 zeros here, and then we get 1, 2, 3 ones. I think this list of zeros are just left out here. Okay, and east and west are swapped. I remember that one. So this looks like east, but actually it's west. This is south. And then southwest is obviously the end between these two. So the king is at 3 zeros here and 3 zeros below it. This is where the king is. 1, 2, 3, 1, 2, 3. Yep. West. From here. South. Southeast, because east is on this side. Southwest. Oh, sorry, I'm counting wrong. This is the one. Yes. Northwest, okay. Calculate the difference between the coordinates of the king and the rook as the rook minus the king that is to move. Difference between the coordinates of the king and the rook. The rook minus the king that is to move. And then add 1. So the rook is immediately above it, so this difference would be 0, 1, and then we add 1, then we get 1, 2. This should be 1, 2. Yep. Now the rook is indeed next to the king. And that's because they both are less than or equal to. Okay, so this sets a 1 on the square where the rook is. That would be C. The rook is on this square. No, that's not true. The rook is on this square. The white king is here, the rook is here, and the black king is here. So there. And it shifts southwest of king. So southwest of king, and then 8 times 2 plus 1. So 2 up and 1 to the left. So that square. No, that's correct. I mean, the king is here. This is the southwest of the king, where west is, like I said, 3 times d4 to the right. And then that is above the black king, which is where the rook is. Okay, so next. This is something with 1 bit set. Calculate the difference between the coordinates of the king and the rook as rook minus black king. I just did it. Encode these delta plus 1 stored in an unsigned int. I already did that. That's weird. This. That was done on 529. And now I do it again at 545. What nonsense is that? Here is the one that is to move. So if to move equals black, then encoded delta well, equals this. That's highly annoying. So to move is black, to move is black. If we get here, then this gets the value that it already has. Calculate the squares that are blocked by the white rook. If the rook is horizontally near the king, it is, because it's on the same row. How many squares are blocked by this rook? Let's see, the white king x equals the white rook x, yes. And is between less than or equal less than the black king, white king. Well, this is not true. The white king is not in between the black king and the white rook. So this should be end up as 0. And here as well, the white king is also not between it in the other direction. So these two should be and there's a knot in front of it. It is actually true. This is always false, therefore this is always false, so this is always true. So we get both west of king in here and then south of king in there. Removed where the rook itself is. Difficult. Top. Ugh, change the line numbers here. Now let's remove the rook square as well. Let's visualize this a little bit better. Can't write that yet. So 1408 08 and then 4 zeros. Oops. Yeah, and the king is here. 1, 2, 3, 1, 2, 3 from the bottom and from the right. And the rook is there. So the rook can be taken, but we cannot go there because of the rook. That would be in check, and we cannot go down because of the rook. That would still be in check. Can also not stay where we are. Well, whatever. Looks like that is calculated correctly. Then block squares is odd with that. I think block squares that is all the 8 squares around the king, around the enemy king. I think so, yeah. Let's visualize these as well. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8 zeros. And I lost count. Oh, that's 4 times, okay. 8 zeros. 1, C, 1, 4, 1, C, and 8 zeros. Oh, 1, 2, 3. Here's the king. That's correct. The black king is where the highlight is, and the white king is there, where the cursor is. Yeah, cannot go there. Absolutely correct. And we order those together. Now we prepare 4 neighbors. Why 4? Prepare the 4 positions where the king steps: north, east, south, and west. It's a new type of king. That can only go 4 directions instead of 8. Well, okay. The block index and block coordinates field types of the king that is to move. So this is K king block index is, yeah, I don't know what it is. Apparently this is going to be used as for the black king square block index and the block square. The reason they are 0 and 1 are because they are field type enum, first and second element. Attempt to calculate the positions that we get by stepping north, east, south, or west with the king. It's just an enum. Increment the y coordinate of the king, increment the x coordinate of the king, decrement the y coordinate of the king, and decrement the x coordinate of the king. It looks sane, but how the hell does it know that? Oh, this, yeah. So we did take the current position and then oh yeah, of course. So neighbor north is just this thing, and then east is that one, and so on, because north was at the top. North, east, south, west as well. So this is a member function that should change the y coordinate of the black king, because black is being passed and No, I don't really get it. But I guess we can skip over this. It should work. And then just print array. And then see if indeed the blocking has stepped in that direction. Maybe we should print success before we call it. Oh. Oh, it's a boolean. I meant to print neighbor. Just wrote. Okay, all the pieces are where they should be at the moment. I think it only returns a boolean, right? So it doesn't change anything, apparently. At least the y coordinate is still 0. What? This one was changed. The rest is not changed. Maybe it's only changed if it is possible. Yeah, that makes sense. So it attempts to go north, but that is not possible because the white king is blocking that. Attempts to go east, that is possible. You cannot go south because it steps off the board, and we cannot go west because it steps off the board. So these three are not changed, and this one is changed into the result, I suppose. So that would be stepping east. X coordinate became 1. Very good. Y coordinate still 0. And the white king is, of course, still 1. 0, I mean. And this is still 2. And then the rook. This is still 0. And still 1. And then success is false, true, false, false. True, 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 false. What the hell? This I totally do not understand. Hello, Moose. Neither at the moment. Just having some function that says that black can do 2 moves. Well, that's not the case. Can only do 1 move. What is the return value of this thing? Increment king. It tells me if the x or the y coordinate must be incremented and which color of the king. And it only returns, well, it returns true if increment field is successful. If increment field is not successful here, return false. Oh, okay, I'm getting it. Yeah. This updates the block coordinate. The coordinate within the block, rather. And then if that succeeds, we stay within the same block. So increment field would return true if we stay within the same block. And So if that fails, then we increment. So this is the block coordinate. The block coordinate is incremented. If it succeeds, we're done. If it fails, we try to increment the block index. So we go to the next block. If that fails, return false, because now we stepped off the board. And if that succeeds, so we get here, then the block coordinate is set to 0. And we return true. So it returns true if it returns true if it succeeded. And false if we stepped off the board. Let's see what increment field was doing. I'm afraid there's a bug in here then maybe, because I don't get it. What I don't get is that if this, yeah, that says it laterally, did not step off the board. So going north, we did not step off the board. Going east, we did not step off the board. Going south, we most definitely did step off the board. Yes. So why is this true? That would be wrong. Northeast, south, west. You cannot go west. That would be stepping off the board. This is also not good. This should be false. So I think we are going to count this as a second move. Okay, so let's step through it then. So did not step off the board. North. Block squares, and is north blocked. Yes, it should be blocked because that's where the white king is blocking us. Yep. Oh, that's how it is doing it. So we see if north goes off the board. If not, then we can also step west and east from that position. Okay, so northeast should be true because we can go there. And northwest should be false because then we step off the board. Yes. But northeast is also blocked, so this should also not be done. Then we test east. Now this is successful and not blocked. So now it's added. This is the one and the only one and correct move. Then we test south. Now south should be false, but it was true for some reason. So this is the bug. Success south should have been false, but it isn't. And blocked square south is blocked because of the rook. And the rook, the rook attacks through the black king and the square that is off the board below the king, so we cannot go here. But okay, we can go southeast, however, because that is not blocked by anything. But it is off the board, so we should not get here. But that's what is being added. So southwest is still off the board and is false. And then yeah, this is not. This is probably just true, yeah, and not blocked. So now we added. This is the second move, and the reason is that this is true. That should not be true. So you have to debug why that happens. Okay. So this one. Let's put a breakpoint here. Run again. Oh fuck. Actually, I should recompile because I changed the file. Put a brick one here. You have a view of those. Okay, I want to stop on Y and it's probably 1. Y and black. I think this one. So Y and black, Y and white. This is also Y and black. Oh no, this is, sorry, this is X. Why do we see so many? 0, 0. Again 0, 0 here. This has a bool in front of it. Strange. Go right back. Hallo Vivek. Yeah. Sorry, Moons. I missed it. I can only answer C++ questions. Any questions about careers or how to get better? The answer is always just work very hard for a few decades. Actually, I know an how old is he? 18 or something, maybe even younger. Author of Enchantum. I think he knows a lot. Like, he's impressing me. So the few decades is maybe not even necessary. If you're smart enough, you study hard. Down. Okay, it's a king. And it's black. Well, if you typed an URL, then I did not see that. The only thing I see is this. For my enthusiasm on the C++ stream, you can probably guess, yes, I'm a beginner, so I'll be asking advice from you. Please say no. Is my approach gonna let me to ditch or will it be productive? What approach? Because it's the 5th time I've changed strategy since I started. I have no idea what you're talking about. Is there a sentence missing there? If you post something with an URL, then I don't see it. YouTube filters it out. For the rest, I don't know. Decrementing the y coordinate I wanted to ask how you practiced C++ problems. Like I'm going for an approach which involves me solving problems on HackerRank and then learning the required concepts from Learn CPP. Sounds like an approach. I'm not a fan of HackerRank or any competitive coding, but The problem with those sites where you have to write something is that they aim for short code, one-time usage. So it doesn't have to be robust, it doesn't have to be maintainable, it doesn't have to be flexible, it doesn't have to be anything. It doesn't even have to be commented. Nobody else will ever look at it. Well, theoretically, not anyone else who is working on the code. So you do not learn to write what coding is about, namely writing maintainable and robust code. Most code is written for such site is just absolutely horrible, even smart but horrible. But okay, I mean, you don't have to write horrible code, of course, but then you will be slow, and all the comments that you get will be laughing at you because your code is, man, it's only 5 lines and you took 50 lines. Well, some stuff like that. But if you can ignore that, then maybe you can use those problems as a motivation. It certainly is better than asking an AI. Yeah, if you don't use AIs, that would be that's very good. So that's why I said it's not that bad of an approach. What you can also do, cough cough, is have a look at my code and then just study that. Almost as bad as using an AI, but I think you could start with using my utils submodel. Yeah, AIs are horrible. Don't use AI. Definitely not to learn from. And not just that they tell you wrong things, but if it works, it's probably still wrong. So the only thing you can verify is that it works. But did they really use the best method? You don't know. Unlikely. And it's just not the way to learn. The way to learn is to get really, really tired. You must have a problem and then work on it and then fail and then think about it and then try again and fail again and then tweak it and then write version 2 and then get a little bit of insight, and then only after you worked on the same problem for weeks and weeks, every time making it a little bit better, then you will be the master of that problem. If you do anything else where like 2 days later you finished it, what did you learn? Nothing. It's pure about time and feeling exhausted and failing a lot and thinking about it a lot. Then it hangs, and then it stays in your memory, and then you will remember it the next problem that is like it. Yeah, okay. I mean, I use AI as well, 5ec. You know, but I use it as a glorified Google, and indeed, maybe, brainstorm a little bit, thinking out loud, like a Robert Ducky kind of thing. And sometimes it comes with syntax that is new to me. And then you do learn something out of the book. But you always have to verify it. You have to be very, very skeptical. It gives you an answer, and that might give you new ideas, but don't believe what it says. It's just a random text. Like in this case, I have absolutely not the slightest urge to copy paste my function to an AI and say, hey, can you tell me what is wrong with this function? Pure waste of time. I'm not going to do that. And it's I'm glad that it is, because all the fun is doing this, just going through it myself, miniatures, step by step, till I understand what is wrong. Okay, now I'm actually going to continue. So xy is 1, which is probably y. That's this y. So you're trying to decrement the y coordinate of the black king. I call that south, but that's for obvious reasons, because we're decrementing the y coordinate. And that is being done by decrementing a field. Which field? Well, the king block coordinate. We are inside some block, and actually on the edge of that block, because the coordinates are 0, 0. The y coordinate is 0. If you subtract 1 from that, you get -1. That's definitely not in that block anymore. So you have to go to the next block. Which I think means that this should fail, because there is no next block. This is within the current block. So it should fail because we step outside of the block. I'm actually going to step inside the decrement field, I think. Step. This gets the field spec. That looks horribly 0. How can the stride be 0? Doesn't feel right very much. Well, this must be false, because this is not equal to x. We're doing the y coordinate. Test if you can subtract fs stride from the current block index. Yes, we can, because stride is 0, and it should never have been. This should fail, because, yeah. This is what makes us step outside of the board. This is 0. Should be 0. But even mask is 0. It also makes no sense. I think this should mask off the y coordinate, which is 0. So that is 0. And then 0 is less than the limit, and going down the limit is 0. I believe the limit is inclusive, so limit itself is still allowed. but the stride should be 1, I think. So 0 is less than 1, therefore we cannot not subtract stride from this value without actually getting below the limit or over the limit. And then it returns false. But yeah, this is not going to be true because everything is 0. 0 is not less than 0. I believe this to be wrong. Which has absolutely nothing to do with 64 by 64. How can this work for a 32 by 32 board? So weird. Yeah, just subtract 0 and then returns true. I think it's time to step through this for a 32 by 32 board. Then it worked, so I'm very curious if then this is not all zeros. Maybe I'm doing some kind of calculation, or the px gets 3 bits or something. So 8 is equal to 0, and then everything turns into 0. That could be it. Where did I have my breakpoints? Board.h 418, I think. Yeah. And then the next breakpoint I put at 5 something. I cannot remember. Yeah. I think I can put a breakpoint here at 644. I think it stopped there, so why not? And then we can do a step. And then we went into this thing. Yeah, here's the field spec. Yeah, what a big difference. So we're just changing those cons expressions from 8 to 4. We get this instead of all zeros. Interesting. So there is a problem with the specialization of field spec. Here's the return field spec. What is that doing? Not really seeing it. const eval field spec. It's a function. Oh yeah, we call it as a function. To call this function, we have the field spec, and then y coordinate is xy coordinate equals y. That should be true. ft is blocking block index. I can't remember. I thought it was, yeah, it was about the block index itself. Probably still see that here. So y field type is 1. Looks like actually the block coordinate. Ah, of course it's block coordinate. Keep confusing those things. So this is the one. Then what happens? The block square shift is the block king square block square shift plus the black king shift. I don't know. I don't look at how many people are watching. But yeah, possibly. I don't understand why do these three things become zero? There's just an editor. Yeah, they're called NeoVim. I need to know all kinds of compilation time stuff. Which I can't print in the debugger easily. Or can I? Or what? 238 and board.h. So the wire mask is pre-shifted coordinate bits X, but for the rest it's not shifted. Block square shift, is that then? It's an analyzes king plus rook versus king on a quarter infinite board. I'm too stupid to wrap my head around this. I wish I could step through this with the debugger. You can't, because it's compile time. Guess you could make another function that is runtime and then step through that. A quarter infinite board. It's an infinite board, but you can still see the corner. You can see one corner. In reality, I'm not working. My board is 64 by 64, but I treat two edges different than the other two edges. Because the bottom and the left edge you can give mate against, but the top and the right edge are just where if you stop calculating, but you can't give mate there. Because the black king can walk off the board on that side, on those sides. My guess is that this is an integer type, so this is 32 bits and I'm shifting it more than 32 bits and then it becomes 0. Now, the reasonable question, what is encoded? I'm afraid I'll just have to print everything one by one. Okay, so let's concentrate on, say, the mask itself. Why not? I'm going to do this in main itself during runtime and then print the stuff. Inf chess2.cxx at the top of main. Yeah. 1. Yeah. Okay, solved. The problem is that this encoder type goes to 8. So doing the doing the shift causes integer promotion. So there's a byte, which is just the size of 1. It's promoted to an integer of 32 bits. But that's not sufficient, because we are shifting at 30, and then nothing is left. It becomes 0. And then I assign it to an unsigned long, 64 bits, but it doesn't work. So you have to cast this thing. Let's use static cast to an uint64 type. Oh, wait a minute, there's a cast. So we have actually an well, that is the type. It should be using that, of course. Before shifting it, I have to promote it to the actual and the final type, not let the compiler promote it to an integer. It's not big enough. And then we end up with some non-zero mask. Yay, fixed. Okay, does this work? Nope. Before I do this, it would be wise to do a commit. Still not sure we want to commit that though. Yeah, I have to do it again, I'm afraid. Hopefully this time it will work. So debug. I definitely don't want that. This one's printing way too much debug output though. Okay, well, it's gonna run many hours again, so I can't continue. Ish. It's filling that one with data now. It is one big file, man. Oh, that is not good. But why? Can go here even. I just made it worse. Oh, the other rook would have been slightly better. Only slightly. Yeah, this I can give this up. No more chess. Go ahead and stop the stream. This runs hours, so no point in streaming. I'll be back tomorrow.